So continuing with the videos that I have been making on the topic of ARPA, today's video will focus on the tracking accuracy of targets as specified by the IMO Performance Standards, and I'll also be talking about the limitations for the tracking accuracy. So if you have been watching my previous videos on ARPA, that's fantastic. If you have missed those videos, then the link to those videos are provided in the description section below. Please make sure that you watch all the videos so as to get a good understanding of this topic. Uh, Regarding target tracking accuracy, IMO actually has a performance standard which specifies so. So all the marine ARPA are required to perform to the tracking accuracy figures as quoted in the IMO performance standards. Now, in the performance standards, the operational scenarios under which the ARPA must conform to are defined under 4 encounter situations with targets in collision and non-collision cases at a range of about 8 nautical miles and 1 nautical mile respectively. These are the 4 scenarios. As you can see here, these are the 4 scenarios which are defined under the IMO performance standards for the marine ARPA. Here you can see the own ship course is 000 in all the 4 cases, but the own ship speed varies in the different scenarios. So in scenario 1 and 2 it's 10 knots, in scenario 3 it's 5 knots, and in scenario 4 the own ship is doing about 25 knots. The target is at various ranges, mainly 8 nautical miles and 1 nautical mile. And the bearing of the target is 000 in the first 2 scenarios and 045 in the 3 and scenario 4. And then you have the target's relative course differing as well from 180 to 090 to 225, and the target relative course and relative speed is mentioned there as well. So the ARPA is supposed to conform to the standards prescribed for tracking accuracy, especially as defined under these 4 categories. Now, of course, the scenarios state the accuracy of track information after 1 and 3 minutes at the 95 percentile. So essentially, an ARPA tracking a target at 8 nautical miles should be able to give the CPA information. CPA is a closest point of approach information to within plus minus 0.5 to 0.7 nautical miles. The TCPA, or the time to closest point of approach information, should be given to about within plus minus 1 minute. The course should be about plus minus 2 to 7 degrees, and the speed to about plus minus 1 knot. So that is what the ARPA tracking a target should be able to provide you with. So the actual scenarios, actual figures actually in each scenario is in the standard. Now most modern ARPAs actually perform better than these minimum requirements. However, the standards do make assumptions regarding range of targets and movement of targets and tracking period, and hence tracked information should be treated with greater caution, because of course when you are at sea you will be not only facing these 4 scenarios, you will be facing many different scenarios. So this is just to the conforming to the performance standard, but it does not describe all the possible scenarios that you may be facing at sea. Now the ability of any ARPA to track the targets is a function of the following parameters: range to the target, tracking period, the echo characteristics or target characteristics, and maneuvering of the target. Now in this video I'll be mainly talking about the range to target and tracking period, and in the next video I'll talk about the target characteristics or echo characteristics and the maneuvering of the target. So when we say echo characteristics, I'll be talking about okay, I'll mention that at the end of the video. Let it be now. So let's start with range to the target. Now before I go into range to the target, you have to know that each of the parameters that I will be talked about will be considered, and the accuracy of the range and bearing information will largely determine the track accuracy. Now with the marine ARPA, accuracy of course and speed inputs of observing ships will also play a major role. And that's where the ground and sea stabilization can create some confusion, but I'll talk about that in a separate video. Now for a standard ARPA, the following track accuracy figures are typical that you can see on your screen. So you have the position range accuracy figure, the course over ground, and the speed over ground accuracy figure. Each of these accuracy figures are in plus and minus. So it cannot be either plus or minus, it is both in the range of plus minus. So according to the manufacturers, the conditions necessary for the above accuracy is of course that the vessel should be a small vessel with only one echo center, the target range should be 5 nautical miles, speed should be 12 knots, target is steaming at a steady course and not changing its course at all, it's not maneuvering, and the target is showing a good echo strength. Now we all know that at sea it's not possible for all these conditions to suffice or to be fulfilled. So they are just taken as a benchmark for some kind of performance standards to be made, but at sea you will face different situations, and that's why whatever information you get from the ARPA regarding targets, you must add a safety margin to that and make sure that your action keeps you clear of any danger to navigation or risk of collision. Anyhow, I'll come back to the parameter which actually affects the tracking of the target, and the first one is of course the range of the target. Now as the range of the target increases, the accuracy of bearing and range information, and hence the tracking accuracy, starts to decrease. So the tracking accuracies quoted are for very short range which are close to the scanner, which of course you know will not be the normal operating conditions at sea. So the radar range accuracy under IMO Performance Standards is plus minus 1.5% of the range scale in use, or 70 meters, whichever is the greater value. Here it is important for the operator to know that you can decrease the range scale to the lowest possible value if you are measuring the ranges and bearings. Now an indication is given by the range cell resolution for a typical ARPA is given in the table as you see on the screen, and you can see how it all works. I then move on to tracking period, and the longer is the tracking period of the target, the more accurate will be of course the tracked target information. Now operators are advised to allow approximately 3 minutes of steady state tracking before using the track data. So when I say track data, I'm talking about the course of the target, the speed of the target, and the CPA and TCPA. Now targets will be acquired after about 37.5 seconds as a confirmed track, but the additional time should be allowed to ensure that the track is settled. An indication of the reliability of the track information can be to observe the vector on the track to see if it is steady since the time we have plotted it. So you have to remember that targets with higher speeds will need less tracking time to give the same CPA accuracy as a low speed target, and targets at a greater range will require a longer tracking period to give the same accuracy of CPA information as a target at close range. Now in this video I talked about the range to the target and tracking period as the parameters that influence the tracking accuracy. In the next video, and this I'm doing that only to keep this video short, I'll talk about the target characteristics. So basically the target echo strength depends on the aspect of the target, the shape, material, texture, and size of the object. So we'll talk about how the echo return from a target is what all the range and bearing information is based on. I'll also talk about the causes of error in range and bearing, and in that I'll also talk about the target maneuvering aspect and how it influences the tracking of targets, and how does track swap also affects the tracking accuracy or causes of error in range and bearing. So I hope you like these videos. Let me know through your comments and likes, and I look forward to it. Thanks guys. Bye.